So question number 20th. Okay, Abhay, Siddharth, Mansi, Sakshi, Ralam, Vadehi, Anika. Good evening to all. So tell me, question number 20 is which of the following pairs of elements would have a more negative electron gain enthalpy? So first pair is oxygen or fluorine. Yes. Which one has higher, more negative electron gain enthalpy? Tell me. Out of fluorine or oxygen? Very good, Abhay. Ralam, great. It is fluorine. Why is it so? Yes, tell me. तो क्या लिखोगे? Fluorine being small in size and has more nuclear charge as compared to oxygen. Added electron is more attracted towards the nucleus. So fluorine has more negative electron gain enthalpy, right? Because fluorine is smaller in size than oxygen, it has higher nuclear charge than oxygen, and because of these two reasons fluorine has higher, more negative electron gain enthalpy, right? Now second, out of fluorine or chlorine, which one has more negative electron gain enthalpy? Yes, out of fluorine and chlorine. Very good, Sakshi. Chlorine. Why is it so? Why chlorine? Because as we go down the group, chlorine is larger in size than fluorine. So fluorine, in case of fluorine, electron gain enthalpy should be more negative for fluorine. But you said chlorine, and which is right. So why is it so? Anika, very good. Ralam, great. All of you, chlorine. But question is why? Why chlorine? Very good. Fluorine is exceptionally small in size, so added electron feel more inter-electronic repulsion which partially nullify the attraction by the nucleus. Okay, so attraction is somewhat decreased. So added electron is less attracted towards the nucleus because of exceptionally small size of fluorine. Okay, but in chlorine, added electron can be easily accommodated because of its larger size. Is it visible? Yes. Or as Ralam said, that in fluorine has small size 2p subshell where electron is added. In chlorine there is large sized 3p subshell where electron can be comfortably placed, but in fluorine comfort is less and therefore it is less attracted towards the nucleus. Got it? So this is question number 20 from chapter 3, periodicity. Okay, so next question, question number 21. We have done it before. Question is, would you expect the second electron gain enthalpy of oxygen, the second electron gain enthalpy of oxygen as positive, more negative, as positive, more negative, or less negative than the first. Justify your answer. We have done it before. Tell me. Is it positive or negative first? Nihal Barot, good evening. Yes, tell me. Second electron gain therapy of oxygen, is it negative or positive? Fast. Respond fast. Very good, Mansi, Abhay. I think all of you have answered it because net is low. Yes, Vaidehi, great. Good. Very good, beta. So, would you expect the second electron gain enthalpy of oxygen as positive, more negative, or less negative than the first? Justify your answer. So, in case of first, when electron is added, it becomes O negative, and when second electron is added, it becomes O2 negative. So this is first electron gain enthalpy, and this one is second electron gain enthalpy. So to get an idea of second electron gain enthalpy, electron is added in already formed anion. That's why there is repulsion. Added electron feel repulsion from the negatively charged oxygen. So we have to do work to add it. We have to work against repulsive forces to add the second electron. That's why energy is always absorbed. So I will write it. See, to add second electron in already formed anion, that is O negative, work is done against repulsive forces because electron is negatively charged, oxygen is also negatively charged. So they repel each other. So work is done against repulsive forces to add second electron. So energy is always absorbed. That's why that's why second electron gain enthalpy is always positive. Second electron gain enthalpy is always positive. Right? Okay, any doubt? This is question number 21. Now question number 22. Anjami? बोला कोई बात नहीं, इसके बाद कर रहा फोन है ना। ठीक, हाँ जी 9 बजे। अच्छा अच्छा, so question number 22. What is the difference between the terms electron gain enthalpy and electronegativity? I think we have done this question. Yes, tell me, do we have done it? It is for all, not with oxygen only. You are talking about second electron gain enthalpy, na? Second electron gain enthalpy is always positive. all the elements. This question we have not done. Is it like that? Means I think in the theory we have completed this question. If not, then I will repeat it. But I have to say you, this question we have done with the electronegativity. In the electronegativity topic, we have covered this. Remember? Tell me. Not done? Okay, then we will complete it now. Okay, Mansi, Anika, tell ki yes sir, we have done. So, could I skip it? Could I skip this question? Because as we have already done it. So, I am skipping this question. Okay? You will do this question at your own. Okay? Now question number 23. कर दो सर. तो लो कर लो भाई. एक राइट वन साइड इलेक्ट्रॉन गेन एंथैल्पी. On the other side, write electronegativity. So you know what is electron gain enthalpy? Amount of energy released or changed when an electron is added in an isolated gaseous atom. But electronegativity, tendency of an atom to attract the shared pair, of electrons. So that means it is tendency of an atom to attract an electron. Okay, to attract an electron from, or we can write from outside, or we can write to attract an outside electron. Means because electron is added in it. Okay, and it is tendency of an atom to attract shared pair of electrons. Right? Now, you know, in this case, we have isolated gaseous atom. But in this case, atom should be bonded. Okay? Means it is the property of an isolated atom, but this is the property of bonded atoms. One is property of isolated atom and other is property of bonded atom. Right? And third is, it is absolute electron attracting ability of an atom. It is absolute because electron is from the outside, it is added to the atom. But here atoms are bonded, so it attracts the electron and it is bonded by the other. So it is a relative tendency. If they both are of the same electronegativity, then shared pair remains at the midway. If it is less electronegative, it is attracted towards this atom. If it is less electronegative, sorry, it is more electronegative, then shared pair is toward this atom. But it is a relative tendency. So it is relative electron attracting ability of an atom. Yes, what are the units of electron gain enthalpy? That you tell. Yes, Siddharth, you are right. But anyhow, it's okay. It has certain specific units. That is joule per mole or kilojoule per mole, and it has no units. There are scales of electronegativity like Pauling scale, Mulliken scale. Okay, there are scales of electronegativity like Pauling scale or Pauling, Pauling scale or Mulliken scale or Rocco scale. These are scales of electronegativity. Scales of electronegativity, okay? For comparison. Is it visible? Sorry guys. Yes, now it's okay. Yes, there are different units: joule per mole, kilojoule per mole, electron volt per atom. Okay. So this is about the difference between electron gain enthalpy and electronegativity. Okay. Okay, so now this is question number, I think 22. Wait. Yes, this is question number 22. Now question number 23. How will you react to the statement? How will you react to the statement that the electronegativity of nitrogen, that the electronegativity of nitrogen on Pauling scale is 3.0 in all the nitrogen compounds. Is it true? Yes. Tell me. What about this statement? How will you react to this statement? Very good. So electronegativity is not constant. So it depends on what? Yes. Write the answer. I will be waiting for your reply. Okay. Electronegativity is variable, oxidizing state of elements. Okay. Okay. What about others? That's right. It is incorrect statement, but just write the explanation. Why it is so? Why is it so? How will you react to the statement that the electronegativity of nitrogen on Pauling scale is 3.0 in all the nitrogen compounds? Electronegativity depends on hybridization. That I tell you on that day. The electronegativity is proportional to S character. More is the S character, more is the electronegativity. Right? So, this statement is incorrect because if hybridization of nitrogen is different, then nitrogen has different electronegativity. Nitrogen has different electronegativity. As S character increases in the order sp3, then sp2 and then sp. In this case, there is 25% S character that we have already calculated. 1 S and total 4p. 1 by 4. 33.3% S character and 50% S character. So as S character increases, electronegativity increases. Means nitrogen with sp3 hybridization is less electronegative than nitrogen with sp2 hybridization, which in turn less electronegative than nitrogen with sp hybridization. That's it. Got it? This hybrid means mixing. When S and P mix, form this type of orbital, sp3, an orbital having 25% S character, 75% P character. So that is called sp3 hybrid orbital. 33.3% S character, 67 something or 66.6% P character, 50% S character, 50% P character. Then accordingly S character increases and so is the electronegativity. Nitrogen. Yes. Any doubt up to this? Siddharth, what you don't know? Is it okay? Okay, done. Siddharth, have you any doubt? Okay, done. So this is the question number 23rd. Now 24. Question number 24. Describe the theory. Describe the theory associated with the radius of an atom as it first gain an electron, gain an electron, B lose an electron. Loses an electron, gains an electron or loses an electron. Okay, so this is the question. So just write the answer. You can write, I know. Just fast. What happened when it gain electron? गेन करेगा तो साइज बढ़ेगा, लूज करेगा तो साइज डिक्रीज होगा बिकॉज ऑफ इफेक्टिव न्यूक्लियर चार्ज, इंक्रीज इन एटॉमिक साइज. दैट्स राइट. ओके, ग्रेट. Abhay, when an electron is added, radius increases and vice versa. Great. So that you know the answer, but I will write it. So when an electron is added, we get anion. When electron is added, an ion is formed. Nuclear charge remains same. Nuclear charge remains same, but number of electrons increases. Number of electrons increases. Nuclear charge remains same, but number of electrons increases. So nuclear charge per electron. I mean nuclear charge experienced by electrons increases, or we can say number of electrons increases, so nuclear charge experienced by the electrons decreases, or we can say effective nuclear charge decreases. So size increases. Any doubt? Very simple. Because electrons increases, so screening effect increases. So effective nuclear charge decreases. Or we can say nuclear charge experienced by the electron decreases, and so size increases. I think you have written the same. Now when an electron is, now B, when an electron is removed, loses means it is removed, means B to form B positive plus electron, means now when electron is removed, cation is formed. Now nuclear charge again remains same, but number of electrons decreases. So nuclear charge experienced by electrons increases, or we can say effective nuclear charge increases. So size decreases. Right? That means cation is smaller than neutral atom, that we have done already, and ion is larger than the neutral atom. Okay? That's it. I think you don't have any doubt in this. Ralph, I am from Himachal Pradesh. Okay, so this is question number 24. Now 25. What are the major differences? What are the major differences between metals and non-metals. Metals and non-metals. So difference between metals and non-metals. Yes. So you can write one by one because you have done this chapter in class 10th, metal and non-metal, or 9th, I don't know, but there it is in the lower class. Okay. So let us start distinction based upon physical properties. Chalo. First distinction on the basis of physical properties. Is it visible? Okay, very good. Just go on writing. Okay, I will check later on. So I am writing property. Okay, property metals non-metals. So I will write the property, you will write the answer. State of existence. First property is state of existence. Yes. What is the state of? Just write first property. Answer of first property. State of existence. Metals and non-metals. Okay, malleable, ductile, lustrous, sonorous. First, solid and liquid. What about solid and liquid? You know, metals are solids at a room temperature. There is only one exception, and that you all know, mercury is only liquid non-metal. Mercury is liquid, except that all are metals. So we don't write that metals are solids and liquids because there is only one liquid. Non-metal exist in all three states of matter. Non-metals exist in all three states of matter. Okay. Second property, luster. I think most of you have written. Metals are lustrous. Metals have shining surface. That is, they are lustrous. But non-metals have dull surface, or we can say they are non-lustrous. So tell me one metal, one non-metal which is lustrous. Non-metals are normally non-metals are non-lustrous. But tell me one non-metal which is lustrous. Very good. Except iodine. Very good. Iodine. Crystals of iodine is an exception. Very good, Daniel. This is an exception. Okay? Crystals of iodine are lustrous. They are shining. Okay? Very good, Ralam, Siddharth as well. Very good. Now, third is conductivity. So, tell me about conductivity. Yes, fast, respond fast. Yes, fast. What about conductivity? We have discussed two properties. Yes, tell me about conductivity. Metals are good conductor of electricity. Metals are good conductors of heat and electricity. And non-metals, they are bad conductor of heat and electricity. So there is only one exception. So tell me, what is the exception? Yes, exception. Right, Anika, Mansi, very good. Yes, graphite, lead. Sorry, Ralam, I don't know that Ralam is also a lead. Lead is a metal. It is not a non-metal. Pb is metallic. Okay. But a lead is not a non-metal. Where you have is it? Yes. Metals. Pencil lead. Beta, pencil lead is graphite actually. Lead pencil means lead because it is when we write by graphite, it is just like we are writing with lead. This way lead pencil, it is called lead pencil. Okay. Otherwise, we can write graphite is an exception, and graphite is good conductor of electricity because it has free electrons. Okay, so this is about conductivity. Then tell me about fourth property is, this is third, conductivity. Now tell me about the hardness. Yes, hardness. Yes, tell me, what about hardness? Metals are generally hard. Okay, except alkali metals, which are soft metals. Okay, and non-metals are generally soft except diamond, which is hardest natural substance. Is it visible? Okay, right. So this is about the hardness. Now next property is malleability and ductility. That you know, malleable means which can be beaten into sheets, and ductility means can be drawn into wires. Metals and non-metals. So tell me. Yes, metals are malleable and ductile. Non-metals are not malleable and ductile. Metals are malleable and ductile, means they can be beaten into sheets, can be drawn into wires. Non-metals are not malleable, means metals are not malleable, and not ductile. Right. Next property is melting point and boiling point. Melting point and boiling point. Yes. What about metals and non-metals? Melting point and boiling point. Yes, metals have high melting point as well as boiling point, and non-metals have low melting point and boiling point. Good. Next is allotropy. Which property is this? Seventh. Yes. Allotropy, and last property is formation of alloys. Yes. Well, very good, Dania. Metals are hard except alkali metals. Okay. Allotropy क्या होता है? Okay, so I let you know. Allotropes means like carbon exists as diamond and graphite. Okay. So they are allotropes. Means allotropes are the atoms of the same element with different physical properties. Existence, I can write its meaning. Allotropy means existence of atoms of same existence of different crystalline forms of same element. Okay, for example, carbon exists in the form of graphite and diamond. Okay, so they are allotropes of carbon. Diamond and graphites are allotropes of carbon. Okay, so that means, you know, so tell me, allotropy, so metals normally do not exist in allotropic forms. Yeah, metals do not have allotropes, but non-metals normally exist in different allotropic forms. Okay, alloys. So you know, metal has many alloys. Metal form alloys. Non-metals do not form alloys except carbon. Carbon alloyed with iron to form steel. Carbon जो है that form alloy with iron to form steel. Otherwise non-metals do not form alloys, but metals do form many alloys. Silver, brass, bronze. You may be heard these names, right? So metals form alloys, but non-metals do not form alloys except carbon. When carbon is mixed with iron, it forms steel. So these are the physical properties of, means difference in physical properties of metals and non-metals. In the next lecture, we will do chemical properties, major difference in the chemical properties. Okay, because we are running short of time. So that's all for the day. Let's call it a day. Thank you so much. Good night all. Bye bye. If you have any doubt, please do ask. Okay, Abhay said bye. Thank you, Anika. Bye. Okay, Ralam. Good night. Bye, Vedhi. Sakshi. Bye bye. Where is Siddharth? Ralam. Okay, beta. Mansi. Bye, Mansi. Okay, Siddharth. Good night.